Have you ever watched a sunset or sunrise where the sky absolutely lights up on fire, but the show only lasts for a few minutes and it's too short a time to go home, grab your camera and tripod, and come back and start shooting? Well, this video tutorial is going to show you how to use the amazing cloud distance tool of Planit, so the next time that happens, you'll be fully prepared and in position when the light show begins. Hey everyone, this is Mike Shaw with Planit, and this video tutorial is going to show you how to use the cloud distance tool for three main predictions. First, you're going to see how to capture brilliant sunsets and sunrises when there's just a thin gap between the clouds and the horizon. Second, you'll see how to capture clouds that are on fire just after sunset or before sunrise. And finally, you're going to find out how to know when there's a direct hole in the clouds right in the vicinity of the moon or the sun or even the Milky Way center. Alright, so let's get started. To begin with, to access the cloud distance tool, drag the ephemeris pages down like this, and then select the cloud distance tool right here at the very bottom. It's the third one over in the last category on Android and the second one on iOS. Now you can see that there's a lot of data on this page, as you can see up here with these colored lines and the information displays, but all of it aims to assist you in predicting these spectacular sunrises and sunsets. And as you'll see, you'll also be able to predict whether clouds are going to cover up the sun or the moon or even the Milky Way at other times of day or night. Now we're going to go through all of this in detail, but first let's take a look at some background information and examples so you know that understand the language we're going to use. Now let's start off by taking a look at this image. You're going to have to rotate your phone, please. Wenji Chao took this photo a few years ago when he went out to this location to shoot seascapes. The time was an hour or so before sunset. It was actually raining at the time, and the rain stopped just when he got there. But he described seeing this bright light along the horizon, and that means that there were no clouds over there. So he waited, and his patience paid off. An hour later, boom, took this photo, and it's pretty incredible. So what happened is when the sun reached the horizon where there were no clouds, the sunlight was able to shine up through the gap, reach up underneath the clouds, and lighten them in this spectacular fashion. After another half an hour, he took this photo. I'll explain why later. But still, pretty amazing, right? And you're going to see how you can find out exactly how to know when these types of things are going to happen, so you can be totally ready and prepared. Now take a look at this image, and this was made on a different day. The sun was at the same place on the horizon, just like before, but the sky wasn't on fire, as you can see, and it just wasn't as pretty. But then, after only half an hour after the sun had set, boom, we got this photo. So look at that. So the question then is, why is it that the sky catches fire sometimes before sunset, but other times after sunset? And good news, you're going to use the cloud distance tool in Planit to help find out the answers, and that's really what this video tutorial is all about. Now, to help you understand what's going on, it's important to understand the relative positions of you, the sun, and the clouds that may or may not be visible in the sky. So let's take a look at these three schematic diagrams to help us explain. Each one of these shows a few important concepts and terms for the three cases that we're interested in. First, the one on the top shows you what we mean by the phrase cloud distance at the horizon. We're going to use this distance to understand the case when the sun slips through the cloud gap at the horizon, as you saw a minute ago in the first example. Okay, so right here's the Earth, and there are the clouds above it, as you can see right here. And if you're just standing right here and looking over here at the horizon, you're going to see clouds all the way down to the horizon like we show right just here. And in particular now, if all of these clouds have the same height, how far away on the ground distance, how far away is the bottom of this furthest cloud? This is important because if we know their height, we can then use some basic trigonometry to calculate the answer. And what we get is what we call the cloud distance at the horizon. And that's just this distance right here. In other words, it's the ground distance from how far away the furthest cloud is from us. Okay, so now let's make the connection back to the first photo. You remember that bright line along the horizon? Well, that's what you see if there aren't any clouds on the horizon. In other words, if this cloud right just here is missing, and the sun can now peek through the gap. And you might be thinking, well, of course, hey, if we're on that location, we can actually just look at the horizon and see if there's any clouds over there. But that's not a prediction, and is precisely the scenario we want to avoid. Instead, what we want to do is to know in advance whether there's a cloud gap at the horizon, so we can decide whether or not to make the trip to catch an amazing sunrise or sunset. So in other words, if you know what the cloud distance at the horizon is, and if you know that you don't have any clouds at that distance, even though you may have clouds overhead on the date that you're interested in, then you know you have a really good chance for a fiery sunset when the sun reaches the horizon. And you can now get the cloud forecast maps online to show you these cloud locations, as you'll see in just a minute. Okay, so now let's consider the second case, and this is when the sky lights up after the sun has slipped below the horizon in the evening, or just before sunrise in the morning. The middle diagram's for this case. And again, this happens when the sun is below the horizon from your location, and here's how this works. This is where the clouds are on the horizon, and it's okay to have clouds here now in this case. And when the sun is setting, for example, it sets all the way down over here, so the sunlight can now reach up underneath the clouds even though we can't see the sun anymore. But the clouds, on the other hand, can still see the sun because of their heights, and this means the sunlight can reach the cloud bottom and the clouds can catch fire. And as the sun sets more, it reaches down here, and eventually it becomes impossible for the sunlight to reach the cloud. And that's when the sunlight is blocked by the Earth itself. But this concept allows us to establish what we call the furthest no-cloud distance. As long as there aren't any clouds to block the sunlight, clouds on the horizon will light up by the sunlight after sunset, and this is what we are talking about in this second scenario. Okay, now both of these first two scenarios are about the sky catching fire, and our third case is now about the situation where clouds simply block the sky during the day or the night, and that's what we are showing by this bottom diagram. So for example, let's say that the sun is up here at a certain elevation angle. And as you can see, these clouds right here block the sun. Now if we know the cloud height or altitude, we can figure out its distance right here, and we call this the cloud distance blocking sun. So why do we need to know this distance? Well, for example, when we take a moon photo, maybe the weather forecast says 90% cloud cover. Does that mean we can't see the moon? Well, most likely we can. Even though the cloud cover is thick, there may be a hole where the moon will show up, and we can still take a good image of the moon. In fact, the clouds can often add quite a strong element to moon photographs and images, so understanding when you can take advantage of them can be very important. We just need to know if the gap in the clouds is at the right place to let us see the right part of the sky. So by understanding this diagram, you can now see how you might be able to use cloud forecast maps to predict whether clouds will block the moon, the sun, or even the Milky Way center. All right, so now that we have this background, now let's go back to the cloud distance tool in Planit. Let's look at these white circles and red arcs on the map. And I gotta admit, it's a little confusing, right? Well, at least we now can begin to interpret what they represent. And what they do is they represent each of the different distances we were just talking about for low, medium, and high clouds. And each type of cloud has its own set of distance numbers, and we can customize them if we wish. So for example, we can tap on the low cloud like this, and we can do that to change its altitude. The range for low clouds is between 0 to 2,000 meters. The default altitude is 2,000. And if we wanted to, we could change it to 1,000 like this. And then you'll see the distance values change correspondingly. Now, if there's no low clouds at all, you can just clear it. So we just clear the text box and set. And it will then show no low clouds, as you can see here. Let's also get rid of the medium clouds. Their altitude range is from 2,000 to 6,000 meters with a default value of 4,000. Let's clear it and set, meaning there aren't any medium clouds in our forecast today. And now if we look at the map, it's much more clean with only the high cloud overlays displayed. Now, the altitude range for high clouds is between 6,000 to 20,000 meters with a default value of 6,000 meters. And for high clouds at 6,000 meter altitude, the cloud distance on the horizon, remember that, is 276 kilometers, and it's indicated by this white circle. So you may remember this from the diagram. This distance here is the cloud distance at the horizon, and that's what we were just talking about. Okay, so the distance in small white text down here on the bottom is the furthest no cloud distance and the corresponding sun elevation angle, as indicated by the biggest red arc, which is 829 kilometers away. This furthest no cloud distance is about 3 times that of the cloud distance at the horizon, you can see, and you'll also see that there's a tiny little red arc in between, about halfway. So you recall from this middle diagram right here that this is the furthest no cloud distance and is indicated by the big red arc. Here's the middle of the two distances where the sunlight just touches the Earth as a tangent, And this spot is indicated by the small red arc on the map, so that's what that means. Alright, so once we understand all these concepts, it's relatively easy to determine when the sky is likely to catch fire. For the first case, which is when the sky lights up when the sun hits a gap at the horizon, there must be clouds in the sky, or at least you must have clouds inside this white circle. If not, that there aren't going to be any clouds to catch the fiery rays of sunset. Now, remember that we have the two cases, the one before sunset or after sunrise, which we've just been discussing, and the second case is after the sun has set or before the sun has risen. You can also think of either of them as when the sun is above the horizon or below the horizon. So, for case number one, when you want to see the clouds on fire when the sun is at the horizon, there must be no clouds there at the horizon. And what this means on the map is that there can't be any clouds at the location of this white line. Clouds in other areas, though, are fine. And for case number two, if you want to see the sky on fire when the sun is below the horizon, as you may recall, this can happen either after sunset or before sunrise. And here, the whole area within the white circle can be filled in with clouds, as long as there aren't any clouds beyond the white circle, or at least very few clouds. And since the direction of the arcs are in the direction of sunset, it's especially important that there should be no clouds from beyond the white circle all the way out to the big red arc in these directions. So right now you're probably thinking, Mike, how do I get these cloud coverage maps? Well, the answer is use the Windy app. And let me show you how to use this amazing app for what we need. Over here on the side, you can select different information layers. Now I'm usually interested here in the clouds, so we enable all the cloud-related layers. You can see. If you don't see these many layers, tap the More Layers button right down here and enable them. Now I usually enable the cloud tops, the cloud base, and all the heights of the cloud. And when we've done that, then we can go back and we can toggle in between the different layers. So for example, right out here, these are the high clouds. These are the medium clouds. And these are the low clouds. And there's also a cloud base, which is the altitude of the bottoms of the clouds. Now for the clouds above us, or in other words, within the white circle, we'd care more about the cloud base. And for clouds in other areas, that's when we care more about the cloud tops. Okay, so after we select the cloud base, we can then go back to the map. And now check this out. Anytime you long press and hold anywhere on the map, you get this pop-up window, and now you can select this Weather Picker Eyedropper option from the drop-down menu. And now look at this. Anywhere you move this little white circle at the base of the eyedropper tool, you can see the height of the cloud base displayed. That's exactly what we're interested in, and I just think that's amazing. And there's some also, so for example, there's some low clouds, as you can see right here. Over here, there are some higher clouds, and so forth. But that's how we get the heights of the clouds. Okay, so let's say that right here is where we decide our camera location is. You can check the clouds on the sunset direction, which is down in this direction over here. And you can get the heights of the cloud base overhead, as you can see right here. So once we do that, our next step is to go back to the Planit cloud distance page and enter that cloud base height right into the field right just here. And this is the altitude of the base of the high clouds for our chosen camera location. Now we see that for this altitude, the cloud distance at the horizon has changed, and the new value is shown right here. We can also see that the sunset direction for this date, and we're going to remember this sunset direction for a minute. So what we do now is we're going to go back to the same camera location in the Windy app, and this time we choose the distance and planning option from the drop-down menu. How cool is this? And look what we're going to do. We're going to use this tool to decide if the clouds are the right size to give us a good sunset. So to do that, we're going to tap right here on the far side of the clouds in the sunset direction to see if they're going to cover up the horizon. And they don't. This number right here is smaller than the cloud distance on the horizon from Planit. This means there won't be any clouds on the horizon, even though we have clouds overhead. So there's every expectation that the clouds will be on fire after sunset. What about after sunset? Easy. Just follow the same line in the same direction and tap here to see the distance to the closest clouds beyond the horizon. Now again, since this number is now larger than the furthest no cloud distance, there's a clear path for sunlight to reach all the way to the bottoms of these clouds after sunset, so we'll also have a great display of burning clouds after sunset. Let's look at this diagram again just to make sure we really understand. Again, so this is the region overhead where there's our clouds, as we saw from the windy app, but we saw that there's no clouds over here on the horizon. And because the light from the setting sun can squeeze through this gap right between the horizon and the bottoms of these clouds, the clouds above us will be lit up by the beautiful red rays of sunset. And correspondingly, after sunset, there aren't any clouds until way out over here beyond our horizon. And what this means is that from the sunset until the sunlight is blocked by these clouds, the sunlight will continue to reach the clouds above us, and we'll continue to see the sky above us on fire. So, based on our analysis, if the camera location is at this point right here, the sky will be on fire for today's sunset. Now, of course, this is a very simple situation, and the real situation will always be more complicated. So you can see what we're considering here to be a tool that you can then use to assist you in making your overall judgment. Okay, so now let's look at the second main feature of this page, which tells you whether clouds you see on the windy app might block the sun, the moon, or the Milky Way center. This information is displayed in the middle here with a larger font. So let's zoom in on the map. Right now you can see that both the sun and the moon are above the horizon and visible in the sky. Since we can only see one value at a time, we're going to choose the sun by default, as you can see here. Now, look here, as you can see this distance right here. What this distance means is that if the high clouds in the sky have an altitude of 6,000 meters, then they are this distance away from the sun, and they will block the sun at this elevation angle. In other words, for a sun with this elevation angle, it will be blocked by a 6,000 meter high cloud that is this distance away from us. Now, and you can also see that as we advance the time, as we do down here by moving this slider, this distance gets further and further away from us, simply because the sun is lower in the sky, and the clouds that blocks the sun, of course, gets further away as well. Okay, how do we see the cloud distance that blocks the moon? Super easy. Just tap right here and select the moon. And here again, you can see the distance as before. You can also check the cloud distance that blocks the Milky Way center. First, let's change the date and time to one where we can actually see the Milky Way center above the horizon, which we're going to do right down here. Okay, so now you see this green line. This line corresponds to the direction of the Milky Way center. You can see that the distance to clouds that would block it is right just here. Again, you compare this with the position of actual clouds in the windy app. Now, okay, as you can see here, there's several choices that you have. By default, we select what to show automatically as the first choice. This gives us the priority of first the sun, then the moon, and then the Milky Way center. So what that means is if the sun is visible, we show the distance that blocks the sun. If the sun's below the horizon, we show the moon, if the moon is above the horizon. If both the sun and the moon are below the horizon, then we show the distance that blocks the Milky Way center. And of course, alternatively, as you just saw, you can just manually select one, find the distance that blocks the specific one that you're interested in and that you select. Okay, so to recap, when you go to actually use this feature, first set the time. That's when you want to take the photo. And then you'll get the distance value to potentially blocking the clouds at basically that corresponding elevation angle and distance. And then you go to the windy app to see whether there's actually a possibility of a cloud presence at that particular distance for that particular time. So finally, let's just do a big old shout out for Windy. We pretty much use that exclusively for all the planning when we need to have weather information. We also recommend it to all our friends and Planit users, and it's really one of the very few apps that we use to cover the landscape planning. Planit, of course, Windy, and Google Earth. And the developers for Windy are super generous, even though we don't know them personally. They provide a huge amount of information, some of which they have to pay for example, this ECMWF model from Europe. And it costs a lot of money to get the data, and it's the most accurate model for weather forecasting, at least at the moment. So the developers of Windy absorb the costs and provide this information to us for free. How great is that? So now we noticed that they recently asked for donations, and this is your chance to show your support by just tapping over here on the donate button. You'll see some choices. You can donate a one-time fee, or you can choose to do it monthly. It doesn't really matter how much. Every little bit helps. Okay, folks, that's it for the cloud distance page. Until next time, this is Mike Shaw with Planit saying best of luck planning with Planit.